My name is Heather Feldman, and I'm a Director of Research and Development at the electric power industry. We're glad that you're here with us today. With all of the buzz that's going on artificial intelligence, the electric power community is learning more about the technology and applying it in big ways. Our objective with our time today is to share some of the thinking about artificial intelligence and how it can transform the electric power industry. Throughout this roundtable discussion, we welcome your participation through the chat feature that's in WebEx. Please take a minute, open up the chat, have it ready for if you have any questions or comments throughout the discussion. To kick off our roundtable, it's my pleasure to introduce EPRI's CEO, Arshad Mansour. Arshad, the floor is yours.
Great, thank you, Heather. It is an honor and pleasure to welcome all of you virtually to this AI roundtable. I look forward to a day, near future, where the event would be in person, but till then, we'll have to use the virtual tools to engage a team of panelists, but also the audience. And as Heather mentioned, make sure you're using the chat feature, not just to ask questions, but to provide your viewpoint on how you see artificial intelligence playing a role in the electricity sector. We're starting a decade where the full digital transformation of how we generate, how we distribute, how we use electricity is going to happen. Artificial intelligence will play a huge role in that digital transformation. And the reason this is the decade to seize on is the technology advancement that has happened just in the last 5 years. If you look at AI, natural language processing, machine language, if you look at processing powers that even 5 years ago was unthinkable, if you look at ubiquitous Internet of Things across our electricity spectrum, generation, delivery, use, all these gives the opportunity for a data-driven decision-making shaping the future of energy, and the energy future that we want to shape is a clean and resilient energy future. AI is not new in the electricity sector. We have been using AI for a long time, but what we are seeing today is applications across the spectrum. We're seeing artificial intelligence for automated threat detection to improve cybersecurity for the power system. We're seeing AI and image analytics across our infrastructure, generation, transmission, distribution, to manage them more reliably, but actually reduce cost. We're seeing innovative AI algorithms to forecast wind, to forecast solar, and to forecast load, especially during key peak hours, what we saw in Texas. These are just a snippet of applications. The use cases for AI is huge. There are a lot of entities, startup companies, universities, technology providers who are working with our members to shape this future. So what is EPRI's role in this? One of the biggest role I think EPRI plays by the nature of our organization, where we collaborate with more than 350 utilities worldwide, is the power of convening. We convene the technology providers, the universities, the startup companies, and of course our members. And this convening is not just through a roundtable or a conference, but actually we use our subject matter expertise with our member advisors. And these subject matter expertise are steep knowledge on generation, transmission, distribution, and use of electricity. And that enables us to produce labeled and curated data sets. And these data sets are coming from our members. And those curated data sets helps the technology providers, the AI algorithm developers, to advance their technologies. We also play a role in ensuring that the knowledge transfer to our members, to the electricity sector, happens through EPRI. The knowledge transfer is key, not just to the subject matter experts or to the digital group within the utility industry, but we need all hands on deck. We need the C-suite, we need the finance group, we need the digital group, we need the operations group, all to come together to seize this opportunity. And I look forward to a very engaging panel. We have a list of panelists, And this is just the start of the journey. Let's all work together to seize this opportunity for digitally transforming the power system for a clean and resilient energy future. Thank you. Thank you for joining. Heather, back to you.
Thank you so much, Arshad. I really appreciate your comments and the backdrop of how artificial intelligence fits into the digital transformation that is happening. We're really fortunate to have 6 AI leaders with us today for this roundtable. And I'd like to introduce the participants of the roundtable. We have Bhavani Amarathilingam from Ameren. She is the Senior Vice President and Chief Digital Information Officer. We also have Jay Singh from CPS Energy. He is the Vice President of Digital and Data Transformation. We have Arun Majumdar from Stanford University. He is the J. Precourt Provincial Chair Professor. And we have Peter Green from NREL, the National Renewable Energy Laboratory. He is the Deputy Laboratory Director there. We have Mirna Bittner. She is CEO of RWI Synthetics. And we have Daryl Willis, Vice President of Microsoft Energy Industry. To start off our discussion today, we wanted to start with talking about artificial intelligence in general. So let's take a look at a broad view on artificial intelligence, and then we're going to narrow down to what's happening in the electric power industry. So Mirna, I'd like to start with you. Is artificial intelligence a new technology? And what are we seeing right now with artificial intelligence?
So thank you, Heather. And I think Arshad kind of introduced it very well. It's not new. So it's been around for a long time. It's been through a winter already, and then kind of is reviving again. And thankfully, it has a lot of road miles on it, and we're still learning. But this is a part of the process, and I think it's really fascinating to bring this to the electric power industry and begin to look at it now that it does have quite a few road miles on it. And I think broadly, it's like a bucket full of tools, and these tools can be applied to all kinds of things: accelerating efficiencies, gaining insights, some very complex tasks. Some self-learning tasks, so things that accelerate kind of IoT on the edges. A lot of evaluative tasks and analytics. They speed things up. So it's kind of like a bucket of tools, but you still have to look at, am I going to renovate my house or am I going to build a new house? And I think outside of the industry, we've had a lot of examples of applications of it. We've had a lot of insight into some of the darker corners too that we should be careful of and mindful of, things to do with surveillance, things to do with how we use personal information, some of the trade-offs that are made in trust and social contract, and then some of the profound kind of capability of artificial intelligence in things like evaluating health data and accelerating things like clean tech advancements, how we combine different technologies and understandings and past data. So I think, outside of the electric industry, there's been a lot of kind of lessons learned that we can pull into what we're looking at now. And the transformation that needs to take place and how we might be able to use this bucket of tools in a coherent way to make that transition.
That's very interesting. So when we're talking about what's going on outside of the electric power industry, Jay, I'm interested in hearing your thoughts on that and some examples there.
Sounds good, Heather. First of all, thank you for having me on this panel. I am proud to be in the company of these exceedingly smart experts in the industry. So before I answer your question, just for the background for the audience, I joined utilities about 8 to 9 months ago. Previous to that, I spent almost a decade in retail as well as quick serve. So I have a lot of the background in terms of how digital transformation is evolving those businesses, right? So as you talk about where is AI making a dent in sort of, making meaningful impacts to how the industry is improving the lives of our customers, I can talk about 2 specific examples, right? So one is, if you think about retail and how digital commerce has really driven retail over the course of last 10 years, and especially in the COVID environment where going to physical stores was really not prescribed. And during my days in retail, one of the ways that organizations would engage with the customers was, their website. And on the website, there are a couple of features which are really, really important. One is the search function, right? So if you're looking for something on a website, how do you know what the customer is looking for? For example, if you go to a website and you say, Halo, are you looking for the Halo video game? Are you really looking for the Halo baby crib or baby clothes? What are you looking for? And so the industry has been trying to tackle this search problem for a long time. And, starting from the VLOOKUP function of if I know the product name or the product details, maybe I can help find the right information. But what AI has done along the way is capture a lot of the other relevant information about the search and really provide more relevant and convenient answers to the customer. So that has been a area where I know AI has made a lot of significant impact. The other area is really the idea of recommendations. When you're buying something, what other pieces are relevant that the company can offer as a recommendation to the customer? And it is so interesting, especially if you think about it. We've all experienced that in when we buy something from Amazon or Wayfair or any of those websites. You put something in your cart, and suddenly you have these 5 or 6 other recommendations. And the industry has gained a quantum jump in the relevance of those products. Are those the right products for me? Are those the right products that goes along with the product that I'm buying? So kind of providing the right recommendation has been very meaningful. But I've seen a very, very interesting trend, especially in the quick serve, right? So if you think about the evolution of quick serve, how we used to engage with quick serve world, we would go to a restaurant, we'd walk up to a counter, we would order a burger and a drink and a fries, whatever it is that you're looking for. But the quick serve industry is kind of moving to the digital ordering. So if you go to the restaurants these days, you will see a kiosk. And kiosk is where you order, I'm looking for a burger and a drink and fries. And now the quick serve is looking for at that digital channel to figure out how to make a right recommendation for you. Should I offer you soft serve as part of your cart? Will that be the right recommendation for you? And I've seen companies making some very significant investment in that space because adding one more item to the cart has significant impact to the revenue, but also significant impact to customer satisfaction. To interpret what this customer would find valuable, how do you assist your customer to be more happy with your purchase? So all of those things go into sort of, how do you make that recommendation? And there's so much data to consider, right? So if you think about it from a location-specific consideration, you're walking into a restaurant in Florida versus you're walking into a restaurant in Minneapolis, or you're walking into a restaurant in San Francisco. The menu is different. The weather is different, and what quantities are available in the restaurant are different. And by the way, the customer who is driving through, maybe a customer who goes through that drive-through all the time, or a customer who has not been to the drive-through in 6 months. So you take all of that data and you're trying to make a recommendation to the customer. And I think this is where AI has shown significant promise on how to make that one recommendation more meaningful and relevant by being able to crunch all of that data and then coming back with a recommendation that makes a lot of sense. So those are some few examples that I think where businesses are finding AI and its ability to crunch data and make meaningful predictions very useful. Not to talk about, one of the AI which is so prevalent in our space right now, is the NLP, right? So I won't even talk about the impact that Alexas and Siris are making in our life, but even if you're using your Gmail today and you're trying to respond to an email, I think the email writes itself. I just have to say, just send, right? So all of that is really how AI is making the life of our customers and ours much easier by understanding the context and then being able to provide recommendations and decisions which are very relevant. So I see huge jumps in how AI is helping us on a day-to-day basis.
Yeah, that's great, Jay. And I see those things as well. I appreciate the help that I can get when I'm finishing a sentence in an email, for example, or when I might be placing an order on Amazon. There's a suggestion there. I may or may not take it, but that's definitely a place where we are interfacing with AI in our daily lives. So Arun, a question for you. What is the impact that AI is having on society?
Well, thank you, Heather, for putting this together, and thank you to EPRI for convening. And as Arshad pointed out, I mean, EPRI has a very important role to play moving forward. So just a little history, we are, obviously AI is thought to be a really important phase. We're entering a very important phase, but this automation and decision making has been going on for a while. The automation started with mechanization, going from human power to machine power, and that started with the Industrial Revolution. And I think we are entering another phase of Industrial Revolution where information is going to be used in an automated way to make decisions. And I think that's the phase we are entering. Now, as Myrna correctly pointed out, this has been going on for a while. When I was a grad student in the 80s, and this was a long time ago, AI was around, and there was neural networks that was used. So what is different now? What is different are two things. One is the amount of data that we have. And as we have more data, these neural networks get better and better and better. And I think that's a big difference that we see now. And the second difference is the compute power that we have, the amount of storage, the amount of computing that we can do. And the combination of data and compute power has really changed the ball game in ways that people had not predicted about 10, 15 years ago. And that is where we are going. And as Arshad pointed out, we are looking at, they have been developed for face recognition, differences between cats and dogs, and of course now even better pattern recognition. We can we can do things like natural language processing, etc. What is not been done, and this is where EPRI can play a very important role, is taking those techniques and adapting them to the electricity world. And this is where we have to be very flexible intellectually about how to do that, because those techniques have not been developed for the electricity world. And also feeding it back to the AI people, some issues that are in the electricity world will require different approaches in AI. For example, when you're doing face recognition, you don't have to satisfy any laws of physics. The grid has to satisfy the laws of physics at every moment. So how do you take an AI and make sure that it's not it's sort of a loose constraint, but it actually follows Kirchhoff's law in every moment? Those are the kinds of things that we still don't know how to do, and that's being worked on right now. But on the other hand, as Arshad pointed out, predictability of wind and solar fluctuating on the grid, if you can estimate it better, you can make a big difference, in fact, financial difference, which market it's going to be entering, whether it's a day-ahead market or the hour-ahead market, and the financial implications are very big on that. So those are the kinds of things, and we are also looking at cyber issues, and we are now living through solar wind, which was detected by an anomaly. And so anomaly detection by AI is going to be, I think, very big in terms of identifying whether this is normal or abnormal, and then trying to figure out what is going on. So I think AI has a huge role to play. I think Murad correctly pointed out there are some dark clouds around it as well, and we have to be very cognizant of how to use this technology. Technology is neutral, but how we use it is up to us. And so I think at some point and early enough, we got to put some guardrails around how to leverage it, and how not to do so as well. And I think this is not just with this technology, any technology, but this is in the early days. And the people who are engaged in it are the best proponents of ethical use of these for electricity and other sectors.
Yeah, Arun, thank you. Those are great comments. And you touched on a few examples in the electric power industry. And that's probably a good segue just to dive a little deeper. And Arshad mentioned EPRI's AI initiative, and we have some information out on our website, ai.epri.com, and we've got our initiative focused around what can we do with asset management in the electric power industry. We also have an area looking at the future grid and how AI plays a role there. And then our third big area that we're focused in on is artificial intelligence and climate change and carbon reduction. How can AI help in that area? So, Bhavani, I'd love to hear your thoughts on some use cases in the electric power industry.
Thank you, Heather. Thanks to EPRI for doing this. And this is, it's a privilege to be here today with this panel. A topic you probably picked that's close to heart for me. Yeah, Heather, in terms of just the things that you touched on, and actually I'm looking at all the Q&A here in the chat session as well. And one that resonates, I think, for all is asset health, right? And we are doing it at Ameren, organizations are doing it. We're actually working with EPRI on some of that. So really, if you think about condition-based maintenance and you think about the billions of dollars of assets that are being managed on the grid across our critical infrastructure, being able to do, predictive, preventative maintenance, condition-based maintenance on key assets, I think it's a fantastic use case. It's great for customers from a reliability standpoint. It's great for customers from an affordability standpoint. So I think that's a huge use case that's currently being consumed by many, and there's a lot of opportunity in that space. And then if you take that, we're actually also using smart meter data. And we've got a voltage optimization platform that really just integrates into our distribution substation, our line devices, and our smart meters to really optimize control and regulation of voltage on our distribution circuits, right? And this drives just energy efficiency and affordability again for our customers. So taking that asset health piece and into what you were talking about as we think about the transition of the energy footprint, one of the areas we're using it on and actually partnering with EPRI on is wind analytics, right? Looking at our, if you think about wind turbines and, gearboxes, right? Like how do you make sure that components in there that you're able to do preventative maintenance on? You're looking at performance, asset performance proactively, and you can save significant dollars, but you can also prevent disruption, and availability from that perspective. So then there's, in terms of taking that to the next level, it is about creating, digital twins that you can effectively use to manage large wind farms, across your footprint. So there's a lot of opportunity there. And I think about, other areas for utilities for our industry that's top of mind when you think about delivering reliable, secure, safe power to our customers. I think about vegetation management and, being able to leverage data and AI and analytics to really go in and, manage tree trimming, look at what's the most optimal approach to it, I think is a tremendous opportunity. We're doing some work around that. But again, it ties both to reliability and affordability, with respect to opportunities there. Jay touched on many things that are being done across industries, right, with respect to customer experience. And I think many in our industry can absolutely take that. If we're doing it where we can personalize experiences for our customers based on their channel of choice and then in which they're engaging, outage prediction that we could be doing, again, using data and AI, as well as a great opportunity that touches the customer experience piece. Natural language processing is being used in our interactive voice response, technology, again, being done across industries, applicable for us as well. And then if I think about specifically, future and an opportunity, an area of opportunity is, if you think about grid network models, they are so important for us, for operators and for planners. And high fidelity data quality is so important in that space. And the opportunity there is tremendous. Then I think about, what we can do with using AI and ML on meter data, and when you think about drone-based imagery data, to detect and automatically correct missing or misaligned data, I think shows tremendous potential. So that's just a few things that, come top of mind in terms of things we are either doing or opportunities ahead of us that, EPRI is also working actively with us on.
Yeah, thank you, Bhavani. Those are great use cases, and there's many of them. It's almost like AI is around us. The opportunities for AI is there. We just want to have the right tool for the right problem. AI can't solve everything, but it can certainly help a lot. And going back to the comment that Arun was making on automation, I think artificial intelligence is a key player with automation as well. So let's shift a little bit. And Peter, I'd like to ask you about artificial intelligence at the national labs. And so what do you see as use cases from that leading edge perspective? Oh, Peter, I'm having a bit of trouble hearing you.
Oh, okay, thank you for unmuting me. Yes, thank you, Heather. Thank you, EPRI. I'm delighted to be a part of this panel. Across the national lab system, there are numerous artificial intelligence and machine learning projects going on. It's actually a key part of where we're going. It goes from chemistry, material science, biology and life sciences, higher energy physics, fusion. And yes, we talked earlier about the future energy system. This is also one of the key areas of interest in the national lab system. This future energy system, as you know, is going to have high penetration of renewables, wind and solar. They're going to be, so to that end, they're going to be diverse power generation sources. You're going to have grid interactive buildings, or grid buildings provide grid services. You're going to be monitoring devices from the Internet of Things, millions and millions of them. And yes, it can't be done by humans. And so artificial intelligence is going to be critical, I think, as Arun pointed out. I want to cover and give you two specific examples, which I view as urgent, but that I think are fascinating. You're dealing with an issue oftentimes when you have enormous amounts of data, and the theory we know isn't very helpful. So one case example is material science. We're now facing some challenges with new materials, right? We need new materials for battery systems, so more efficiency and safety. We're looking at power electronics, which are going to be a key part of this new power system. And so what we like to do then is identify what are these new materials? How do we replace, for example, some of the critical materials that are not readily available anymore? We need earth abundant materials. It's a hard problem. And it's hard why? Well, if you think about the elements out there, the number of materials that can be produced are virtually limitless. And they're going to exhibit all kinds of properties. And the theories that we have and the understanding we have, sadly, after a few decades is limited. And so what you want to do then is that these deep learning, learning approaches are going to be really, really critical to be able to predict structure and composition and provide a lot of guidance. And so with this urgency, we will not escape without the help of machine learning. And there are other places where, for example, you can sort of predict the future of a system. I gave an example of materials. We can look, for example, predicting the future of how do you manage traffic controls in airports in the future. The next example I want to give you is one I think rather fascinating. We know a lot about image processing from and social networks from machine learning independently. In the energy space, some of the ideas from imaging processing are becoming quite useful. So take, for example, we talked about wind and solar. If you want to do planning for power production for community, you have to be able to assess what the resource is like. So wind, for example, you want to get the wind speeds at different times of the day throughout the year, solar irradiance, and what have you. However, one of the challenges that we're looking at is that some of the global climate models that produce data is at very poor resolution. And so how do you take data at poor resolution and make it sort of a higher resolution that is quite usable? And this technique is known as super resolution from imaging processing ideas. So what we've managed to do is to actually take wind and solar data and use this data to train these deep adversarial learning, machine learning algorithms. And by doing this process, we're able to increase the resolution of wind by a factor of 50 and solar by a factor of 20, just from machine learning alone. In fact, this is a paper that was just published recently in the Procedures of the National Academy of Sciences. So this is yet another example of sort of taking a lot of ideas developed before and applying them in the energy space. And so these, I think, are really interesting things that are going on right now. And so I can talk more later in the question and answer section in terms of what we're doing with interactive buildings. But I thought these are two key areas of interest. But bottom line is here to stay, on the national lab projects across the entire national lab system depend a lot on AI and machine learning techniques.
Yeah, thank you, Peter. And I have a question about data, but I'm going to hold that for just a minute, and I'll come back to it in just a minute here. So Daryl, you work with Microsoft, and you're considered an artificial intelligence provider. So you've heard a couple of use cases within the electric power industry. I'd like to hear your perspective on what do you see as use cases in the electric power industry, knowing the technology that you have. Daryl, I'm having a bit of trouble hearing you.
Okay. Can you hear me now?
I can, thank you.
Can you hear me now?
Yes.
Okay. All right. I was saying I've just really been fascinated listening to the conversation so far. And, you know, there's been some interesting examples that have been covered by Jay and by Bhavani and others around kind of maintenance and predictive and preventive maintenance issues around wind turbines out in the field, as well as things like vegetation management. It all kind of culminates with something that Arun said around just the extraordinary amount of data that's being created that we need to be able to see around the corner using the data. And that's where I think the elasticity of the cloud becomes very, very important. That's where I think the ability to do complex competitions at pace becomes really important, particularly as we think about what's possible around real-time settlements and the integration of wind and solar energy into the existing grid system. But when I was thinking about this question, one of the things I thought about was kind of what is Microsoft doing with data? And a great example that I wanted to share with the group today comes around applying AI, comes from inside of our company. We've got over 144,000 employees, and we have an extraordinary real estate footprint around the world. And our goal, one of our goals, was to take the technology that we talk about a lot and apply it in some of the best practices associated with it in an effort to sort of sustainably improve our operations and the efficiency of our operations. So we looked across all of our carbon emissions and energy consumption to identify a strategic plan that included using some of our cutting edge technologies to help us meet our goals. And one area we considered as an example was the energy spent on heating and cooling of our real estate. Obviously, this was pre-COVID. And our belief was that we should be able to use AI technologies to improve the efficiency of our systems and to reduce our energy usage across the real estate portfolio. And to teach the AI, the team first had to give it an objective. And the objective was, in this particular case, to reduce the energy consumption while maintaining a desired temperature across the portfolio. And from there, the AI had to understand some of the variables around the controller options. And it also had that it could change in order to achieve this goal. So we worked with a project called Bonsai to help develop the ambitions around this, and it returned with some very, very interesting observations that were counterintuitive to what we thought probably going in. And when I say that, what do I mean? I mean counterintuitive in that many people might assume the AI, well, when I say that, what I mean is that AI recommended increasing the set points at the cooling towers and the chillers, which was counterintuitive for us, while also increasing the speed of the pumps that were delivering water to the systems. And the overall goal by doing this, by increasing the cooling towers and chillers and increasing the amount of water going through those systems, we were absolutely able to reduce the energy costs while maintaining the desired temperature across the building. And so I say all of that to say, by leveraging AI in this particular case, we uncovered recommended options that would have never, ever come to, we would have come to on our own in the old traditional ways we use to manage our business, our real estate portfolio. And that outcome was a new plan for optimization that essentially took 2 weeks to discover, with a plan that is expected to deliver us something on the order of a 15% cost reduction across the portfolio, and pretty remarkable efficiency gains were achieved in a relatively short period of time and using very limited resources, all thanks to AI.
Thanks, Daryl. That's a great example of how artificial intelligence can be used to basically increase energy efficiency, decrease the overall carbon footprint. And that's a really, really great example. I've heard all of you mentioned a little bit about data. So let's talk a little bit about data. At EPRI, we're creating the EPRI 10. These are the 10 most valuable data sets. These represent the global energy utilities data. We're in the process of collecting, curating, and in some cases sharing those data. I've also heard data referred to as the new oil, or data is the new gold. So let's talk about data for a minute here. So Peter, I want to go back to you and get your thoughts on, what are your thoughts on data?
Okay, yeah. What I find rather fascinating, I read somewhere that every 5 years, the amount of data generated increases by about a factor 10. And so by all estimates, by the mid-century, the number of bits is going to be measured in maybe hundreds of septillions. The septillions tend to factor 24. So that gives you a sense of how much is out there, right? This data is, much of it is of significant value, and some of it is also proprietary. But there's no way we're going to make sense of it without artificial intelligence. And just as an idea, this morning's issue of Nature just came out. Actually, IBM has just published a paper that talked about an autonomous debating system that they've developed that can engage humans. This is just one of a number of creative things that are going on right now. The challenge, though, and we've seen this in the media, is that you have to think really carefully about the quality of the training data that one gets, and also the effectiveness of the machine learning algorithms. We've seen cases of mistaken identity and things like that that we're dealing with. And so the other issue is because some of the data is proprietary. How is it shared between different entities to ensure that some of the algorithms are working in the way that they should? The consequences can be rather negative, again, for using training data that's not really appropriately understood. You see, for example, fraud in financial markets. If we look, for example, at the grid, for example, right, we're going to have to build a grid that's going to be resilient. Namely, it's going to have to operate in the midst of disruptions suboptimally instead of shutting down as it does right now. Where about cybersecurity issues? And so this is something in the end we're going to have to be able to do appropriately. Otherwise, they're going to be major consequences as we go down the road. It's not just going to be mistaken identity as we're dealing with right now. So that's sort of my sense of where we are.
Okay, well, very good, very good. We've also touched on, explainable AI. We've touched a little bit on synthetic data or super resolution, Peter, as you mentioned it. And I know, Mirna, your company works with synthetic data. So what are your thoughts about data?
Oh, I have so many. So I'll get a little bit more personal to just kind of let people know. My company is, we do synthetic modeling. People have been talking about synthetic data in the chat, and how, there's been discussions about how we need to see around corners, and really this is kind of the double-edged sword. So the initiatives that EPRI is undertaking to accumulate and make accessible the data that the AI industry needs to actually build relevant products is huge. That's a big step, and I think it will bring that AI closer to being relevant, to being validated, expedited. When I talk about getting personal, we entered energy just a year and a half ago, so we're relatively new, but we have been doing synthetic modeling for 7 years. And the modeling that we do is really to expose and explore data that doesn't exist. So that's always one of the biggest blind spots about data. And when we say we're accumulating more and more and more, the more you accumulate, the more you realize you don't know, and the more data that is blind to the system. And we can only train systems, as good as the data that we have. So when we entered energy, we entered through the Incubate Energy Labs program, actually, and had a chance to be impacted by the lack of data or the data delays in several ways. One being that we were creating a synthetic model of a dual disaster, so something that hadn't happened yet for Salt River projects inside the Incubate Energy Labs project. They wanted to look at the effects of COVID-19 during a disaster or an outage. COVID had just started, so we were just beginning to realize that a lot of the AI forecasting that had been trained on historical data about how people consumed power was being disrupted because the movement and control orders had shifted human behavior. The grid is kind of realizing that it's actually powered and driven by human behavior and activity that had been quite consistent for some time, but really had a dramatic shift. So we need to connect once again with some invisible data source of people and how they actually use the grid. And then we were also impacted because the data is that tells us where grid assets are and standard consumption patterns, of course, is very proprietary and regulated. And there's a process of accessing it that just is not anywhere near fast and available. So, there is this need for what data do we have and how can we make it accessible to things that can help us with the future of our grid, but also what data do we not have and is likely to challenge us constantly, and that's data about the future and things that haven't happened yet or things that are invisible to us. And that is another thing that AI is tackling in synthetics, is being able to model those things and actually produce the data and use that to inform the system. So, data, I think, is critical. Can't say enough about the data that we're gathering, but we also need to be really cognizant about the data that we don't have and make sure that we incorporate ways of building that and understanding that and respecting it too, being humbled by it, and make sure that we don't assume too much.
Yeah, thank you, Mirna. I appreciate the very personal viewpoint on data and what you've done with your company. And Jay, I'd like to hear your thoughts on sharing data.
Yeah, Yeah, great question. I think the topic of data is really it's very central to how do you make AI useful, right? So I go back to what you said earlier. You know, data is likely like new oil, but if the oil is in the ground, it only has potential but no value, right? So I think to that degree, if the data is sitting in our databases or our computers and our systems, and it's not being leveraged for decision making or for modeling, then it's not really being used. So I see several reasons why data sharing is very helpful, especially as we're trying to address some industry level concerns and questions around how do we leverage AI from asset management perspective, from vegetation management perspective, and cybersecurity, resiliency. There's just so many areas where we need our individual and our collective data to help us make some better choices in the future. So, you know, a couple of things that are kind of front and central in my mind as we think about data for the industry. Number one is, you know, the idea of, you know, we all have data in our kind of four walls, and the data that is in our four walls has the bias of our four walls. And so as we are training AI or machine learning, we have to be super thoughtful about what biases are we introducing to the AI. And you know, as we start to combine data from different four walls, hopefully some of those individual biases get canceled out. That's one hope. And second hope would be, how do you look at industry-wide biases in our data and then account for that as you bring together all the data and you start training your models, right? So I think what's important about that aspect then is, how do you think about the framework for data? How do you think about what is right data, what is wrong data? And it's not, I think it's a question that each individual organization has to address, but a organization like EPRI providing some of that framework around how to address the biases in data. How do you think about what's good data, what's bad data, what's the right format for the data, and what is the data that we need? Because there's so much data, right? I think all of that framework development, it's truly very helpful. And as we kind of combine the data from the various organizations, it truly helps us take advantage of you know, all of our collective information and make use of you know, making AI more useful. I think the other piece that is important is, you know, we keep hearing how AI needs a lot of data. We all believe we have a ton of data, but do we have enough? Do I have enough data at CPS Energy to truly build an AI model that can actually make good predictions? And I think that's once again where we can help each other out by combining our data in a way that helps all of us out, right? And so I think that's another advantage of, we may have enough data, but we may not have enough. We may have a lot of data, but may not have enough to really train AI. And if we combine all of our data sets together and feed our AI models, whether it is vegetation management, whether it is you know, image recognition, whether it is kind of, you know, transmission or distribution management, how do we take all of our data and bring it all together in a way that it really is a good set of data, cognizant of the biases, and in a proper framework that actually leads to good output. So I think there is a lot of upside to data kind of sharing. And the other piece I think we need to pay attention to is that even if I have data, even if all of us have data, do we have the right tools and talents to do something with that data? And if not, that's the third piece where I think data sharing helps us, where, you know, we can take advantage of really good tools and access to talent which is needed to do something with this data and the AI to come out with the outcomes and the outputs we're hoping for. So I see tremendous advantage in collaboration more broadly, and data becomes one element of it, where someone like EPRI can you know, give us some guidance and framework that we can all take advantage of, but also access to the right tools and access to the right talent that really helps us all come together solving some critical industry level challenges that we have. So hopefully that provides some context around my opinion on sharing data, and I'm for it.
Yeah, Jay, I think that's great. And you touched on having the right people. And, thus far we've talked about artificial intelligence being a tool. We talked about some use cases. We talked about data. The people in the workforce are critical to really deploying artificial intelligence in the electric power industry. EPRI's been working on a DOE-funded project called Great with Data. It aims to create a pipeline program to pull AI expertise into the electric power industry. So let's spend a minute and talk about the workforce. So Daryl, I'll start with you, and from where you sit, from your organization, how do you see the workforce changing? How do you see jobs changing?
Yeah, thank you, Heather. I love that project name, Great with Data. I love that a lot. It's really, really sticky. But to answer your question, a few examples come to mind for me, and I guess the first thing I would say is that we increasingly see AI, and that's kind of been reiterated over the course of this panel. AI is increasingly important to the industry. But I also wanted to say that we see AI, I should say, as an assistant, not a replacement for folks in the industry. It is to complement the expertise and skills that are required across all of the aspects of energy that we look at Microsoft, whether it's oil and gas, power utilities, mining, and renewables. We see AI as an assistant, and it's increasingly becoming a bigger assistant. That's been alluded to this afternoon. I'd like to share a couple of trends that we see across some of the verticals in the energy businesses that we are working with around how customers are trying to streamline their operations as they think about and evolve to new business models. So one example I share is that by 2022, 90% of oil and gas majors will have deployed AI-powered applications across various exploration processes, ranging, for example, from automated drilling to cognitive seismic data analysis onto reservoir simulation. That's a big deal, and that's a huge shift for that particular subsegment of the industry. But also, if I think about bringing it back to utilities, while developing new business models this year in particular, utilities will put something like 80% of their execution efforts into modernizing the core, with an emphasis this year and beyond, frankly, in applying AI to customer, to asset, and enterprise operations. And the last example I'll throw out is one that we are seeing as we look towards 2022. Again, 70% of water companies will have deployed advanced analytics and AI on telemetry and operational systems data. Ultimately, we believe reducing leakages, power, and chemical usage by something like 10, 15, and 30% respectively. And the last thing I wanted to say was just kind of bringing it to a specific customer example. I think about a company that we work with at Microsoft, Excel Energy, and they're doing something that, again, has been referenced amongst others as well, in using drones and AI-based technology for power grid inspections. And as you all know, grid line inspection is one of the top 10 most dangerous jobs in the US. And this solution that's being applied is really helping to make that a much more safer experience. It's doing an extraordinary job of keeping people safe. It's also allowing Excel to extend asset life. It's allowing them to reduce lower maintenance costs as well as reduce failure rates. Again, that application is directly good for the utility industry, but it's also being applied to the wind industry as well, in terms of blade inspections for turbines and things of that sort. So there's a lot of great applications as the industry evolves and starts to embrace AI more powerfully and see it ending where I started, as an assistant for expertise in all that's going on across the space.
Yeah, thanks, Daryl. I think that assistant analogy is really a great one. Just describes that complement to the expertise that we have, say, in the electric power industry. It's a wonderful analogy. Bhavani, what do you see as skills that are needed in the electric power industry today and then 5 years from now?
Yeah, sure, absolutely. I think Daryl did a fantastic job just articulating some of the change that's happening. And the statistics that he provided obviously is pretty eye-opening, right? And so, a couple of things I will add just for folks to, just again, the part of this is just a mindset shift, right? That needs to happen with respect to skills. And I think about whether it's the electric industry or even just broadly, if one of the stats that the World Economic Forum released, in terms of future of jobs was that, 1/3 of the skills that are there today will have changed in the next 5 years. So I find that, and, the other stat that always sticks for me is what used to be the half-life of a skill used to be 30 years is now 6. I mean, I think, so the most fundamental thing, whether you are 19 and in an undergrad program or you've been in the electric power industry for 25 years, I think the most important thing to do is that the mindset of continuous learning just, I think, is very foundational. And so I think that's one that, in terms of message that I want to make sure I leave this audience with. And then I think about skills itself, again, broadly, when you think about the electric industry, but it's also applicable across the board. In our industry, I think there are two key things that need to kind of, come together. You have domain expertise, the experts, inside of whether it's your distribution, your transmission, your generation functions, your back office functions. The future of finance is going to look nothing like it did, 2 years ago, or it looks like today. And so taking the domain expertise that's there and then the technology expertise, with respect to all of what we're talking about with respect to the tech skills around AI and ML, and really bringing those two together, I think is where you will get scale. And when you talk about where we've been able to overcome some of the challenges you get with respect to adopting and implementing the newer technology, new ways of working, it is really about bringing those two pieces together. So I think that is a really important aspect. The other thing I would say is, think about the skills of the future in two realms. One, which we all think about in the context of maybe the left brain, which is, I'd say strong, what we need is strong analytical thinking, critical thinking, judgment and decision making, right? That's going to be key technology skills for the future. And then I really do believe, I think Daryl did a nice job. He called it, assistant. I think about technology really enhancing human performance, and that's really what it is. And so when you think about the right brain characteristics, they are going to become more and more important. And so really making sure creativity, communication skills, EQ, just the ability to embrace change. I think there's going to be a greater need for that than there has ever been before. So, because sometimes you can get a very utopian or a very dystopian view of AI and automation, and it really is not the case. I think it's figuring out how we evolve in these aspects. So hopefully that gives, some perspectives for the electric and power industry, but just also across industries, with respect to how to think about skills and how to bring the different skills together in our existing workforce, as we path forward.
Yeah, thanks, Bhavani. And the statistic that you gave, that it used to be skills the half-life of a skill was 30 years and it's now 6 years. That's impressive, and it really points to the need for continuous learning. And you also pointed out the diversity in thought that's needed. Exercising the left side of the right side of the brain, bringing different people together is really what's needed to harness artificial intelligence and apply it to problems. I'm looking at the chat here, and there's really great questions and feedback and comments that are out there. And so we're going to wrap up the discussion here and turn our attention to questions in just a minute. And as we wrap up, I really wanted to think about the future and wanted to think about, where is artificial intelligence going to take us in the future? How is it going to shape the electric power industry in the next 5 years? So, Arun, what are your thoughts about the future?
Well, thank you, Heather. And it is great to see all the questions. I hope someone is preserving all these comments and questions, because they are very rich in their content. First of all, if you just step back for a moment, what you realize is that there are these $2 trillion industries. One is the electricity industry. Globally, it's $1 trillion or more on the order of. And you got the data and information industry that are now intersecting in ways that probably they have not intersected in the past. I mean, I used to work at Google, and I know that Daryl worked out there too. And now he's at Microsoft. And it's important to point out that the people who are focused on data do not always understand the issues related to the electricity industry, and so and vice versa. That is, the amount of knowledge that is there to handle data in these information industry. I don't think the electricity industry is aware of that or what can be done with this. So I think it's very important to, when we look at this connections between the two industries, you have EPRI, the universities and the national labs kind of in between, trying to help in connecting the dots. And I think the faster we do that, the better off we are in terms of de-risking things, because anything new in any industry is risk. And so the de-risking part, and as Daryl pointed out, they basically used AI on themselves and see what outcome happened. This is like eating your own dog food. That's de-risking. And there are lessons learned from that that could be utilized with the electricity industry. And I think that de-risking is very important. The second thing I would say is that there's going to be a lot of data. I think we all agree. There are security issues with this. There are privacy issues with this. There needs to be anonymized data sets that could be used. And this needs to be at scale. And the scalability of organizing data and making it useful is something that the information industry understands very, very well. They have techniques that the electricity industry does not have. And so trying to create and having EPRI provide that connectivity in scaled data sets and create a data commons. In fact, there's a nonprofit that spun out of Google called datacommons.org, and that should connect with EPRI, and I see a wonderful partnership out there to get the best of the electricity sector and the information sector. It's two nonprofits coming together and really helping out. If you look at the future of the grid, and it's pretty clear that we're going to have a lot of wind and solar on the grid, and the grid was never designed for it. We're going to have a lot of DERs, EVs on the grid, and a lot of fluctuations on the demand side. Now you got, volatility on both sides of the grid. And that requires orchestration. And that orchestration needs to be done with some level of automation. And I think I'm so glad to see, Microsoft kind of moving in this direction and in providing the orchestration layer that needs to happen on the DERs. And now that FERC 2222 has happened, which is wonderful. The question is, how do we do it in a way that provides stability in the grid while still providing the services? This is going to be very, very important. And let's not forget that we cannot leave any communities behind out here. So there are environmental justice and equity issues. And if you only take data sets that train for one part of the society and not the other part, we would not be doing proper justice to our communities around, not just around the United States, this is around the world as well. And so I think it's very important to keep in mind as we move forward in de-risking and leveraging this amazing technology that we keep in mind environmental justice and equity, and we cannot leave behind certain communities in this process. Finally, I would say just part of the de-risking, since EPRI is kind of right in the middle of all of this, it would be terrific. There are obviously some short-term, mid-term, long-term issues. In the short term, as we heard, things like trying to predict maintenance and all of that. This can be done now, and certain use of image and pattern recognition on predicting wind and all this can be done today as well. So these are short-term things that are already happening. It would be useful for EPRI and the community to put out some midterm and long-term challenges that would be looking at where the grid is going and putting out these challenges for the community broadly, both the information community and the electricity community coming together, so that once those challenges are addressed, these are like canonical examples. If you address them, it opens up a whole new industrial use of AI in the electricity industry. So I think those kinds of challenges out there would really it's like the DARPA challenge that happened for self-driving cars. And without that, Waymo and Google would not have gotten into it. That triggered the whole industry to happen. And I think those kinds of challenges moving forward are going to be very, very useful. So let me pause here. There's a lot to talk about, but I thought those are the kinds of, if you step back, you see a convergence of these two industries coming together, and there's a lot at stake. And to accelerate progress and not leave communities behind, I think EPRI can play a very important role, and so the national labs and academia.
Yeah, thank you so much for all of those comments. I cannot wait to get to work in those areas. And the theme that I heard throughout was really collaboration and working together. And, EPRI, the national labs, the university can be a part of that and can absolutely collaborate together around the common model that you mentioned, around putting together some short-term and long-term challenges. I think those are both great ideas that I'm absolutely going to explore more with you and the team at Stanford. So, Peter, looking to the future, what are your thoughts about AI and electric power?
Yeah, sure. So we, of course, as a planet, have to meet certain decarbonization goals in the near future, next decade or so. And electrification is going to be one key component of the strategy, because it will lose, electrifying everything is going to reduce to reduction in energy use, CO2 reduction. And a key part of this is, what would the energy system of the future look like? Arun alluded to this, but essentially, it's going to have a high penetration of renewable energy resources, up to 80–90%. We have to figure out how to do that. They're going to be distributed energy resources, tens of millions of these, ranging from smart devices across the board to rooftop solar, energy storage. They're going to be grid interactive buildings and what have you. And this energy system is going to have to function through uncertainty, right? From cloud cover to uncertainty of wind, cover there's no sun shining at night, things like that. And you're going to have to be able to manage this in such a way that the grid, the supply and demand are balanced. If they're not balanced, there's a problem. Texas is a good example. And it has to be done literally every second and every hour, which means that you're going to have to develop the technologies to be able to accomplish this. This challenge cannot be done by humans. It's going to have to be done by artificial intelligence. And it's going to involve optimization theory, control theory, data analytics, and machine learning. We can accomplish this in some small communities. And in fact, Ameren has done so in a small part of Colorado, where you have these communities that generate and store their own power and interact with the grid. These are big challenges going forth for large cities. There's the LA 100 study, which is going to introduce later on this week, that Ameren did with the city of Los Angeles. How do you get to 100% renewable energy? Aaron talked about environmental justice. We engage stakeholders in trying to understand, essentially, how do you serve some of the underserved communities and making sure that you're doing something that's of value to everybody. If we don't address the environmental justice or equity or energy equity challenge, we will not solve the decarbonization problem. So it's an intelligent thing to do, no matter how you look at it by and large. But this LA 100 study is the largest simulation ever done. We simulated every single building, every residential area, every industry, every wire that carries energy, that's been a part of that simulation by and large. And I think this is what the future is going to look like. And we could not have done it without machine learning, artificial intelligence.
That's wonderful, Peter. All right, as we're wrapping up our last thoughts here, Mirna, I'll turn to you and just what's the future?
So I so enjoyed this discussion, and you know, one thing I guess I can add, you know, on top of what other people have described as the future, is that I think with decarbonization, we're really realizing that there's a lot of decentralization. And the decentralization of the grid is something new. The disruption from electric vehicles and self-generation and is really, you know, kind of changing the perspective on what we need to understand about the grid. And I think we need to, you know, not only between the artificial intelligence community and the data community and the electric power community, we need to incorporate a vast array of different sectors and their knowledge. So we need to understand and be able to build systems that that can understand how changing policy, changing environment, changing human behavior, activity, diverse communities and voices are all a part of the new systems that we're building and the responsiveness to those systems. And part of that is being able to reach out and interconnect those different environments so that we aren't just building a grid that preserves the grid as we know it, but that we're also building a grid that has all of these new, very dynamic edges and understanding, and that can see opportunities in some really innovative approaches. So when we're, you know, looking at reliability and resilience of the grid, that we're also calculating and factoring in the very human impacts of those decisions into our investment calculations. And so I think that's part of the future of artificial intelligence too, is to, when I was saying before, realize the data that we do have and that, you know, that doesn't become its own self-fulfilling prophecy, that we stay inside that data, that we also begin to really look out and connect energy and electric power to all of the other kind of aspects of the environment that it will be operating in. Not just today, but in some of those really impactful scenarios that we anticipate in the future.
Thank you, Mirna. I appreciate that. Jay, let's hear your thoughts on the future.
Thank you. Great question. So here, I would kind of add a little bit of a sort of current events tone to it, right? So as we think about the future, not only just for energy industry, but future for all of us, right? So it would appear we have entered what I call the age of crisis, right? Whether the crisis is introduced by environmental issues, political issues, biological issues, whatever have you. In the last 18 months, we've seen all of it, and I'm sure more is coming. And as you think about the key tenets for the energy industry, and Mirna kind of pointed to it, and so did the others, the topic of resiliency is extremely important. As we are moving through this age of crisis, how do we make sure that we are able to provide affordable, safe, reliable, electricity and power and energy, which has the resiliency to deal with this nonstop crisis mode that we are in. And so I am very interested to see how AI helps us not only identify the right spaces to invest in from developing that resiliency, because resiliency is expensive. Historically, you do resiliency by just building redundancy, and you cannot build redundancy for once in a century environment situation, because that's just not cost effective. So to me, leveraging AI to really kind of think deeper about how do we prepare ourselves for future crises, because they are coming, whether we like it or not. And how do we think about investing in the right areas, and how do we think about being prepared, not only for the crisis, before the crisis, what is my resiliency? just before the crisis, what am I doing to get prepared? And post-crisis, how am I going to address all the things that stress my resiliency? And I think there should be a lot of industry-wide effort and focus on this space. And I hope to see AI playing a significant role in that space.
Thank you, Jay. Bhavani, what are your thoughts on the future?
How do you follow all of them? It is, I think, very well put, together by co-panelists here. I think about just the disruption in the electric, just the energy industry broadly. I think about it in the context of 4Ds, the digitization of the grid that's happening. We talked a lot around data, about connected devices, that's creating all of it. The decentralization and the, decarbonization that Myrna touched on, and the change in demand patterns, right? How customers are consuming energy is changing. So if I look at the 4Ds and how that's disrupting our overall industry, I think technology has a key role to play in the future. And so if I take that into all the things that have been touched on, and I think about the future of our industry, I think we have AI analytics automation has a key role to play in enabling our customer-centric business models that involves a two-way flow of energy, seamless personalized experiences and products and services for our customers that we've touched on today, productivity and efficiency, in our operations that support our affordability posture for our customers, and providing reliable power supply we've talked about, that I think there's tremendous opportunity in driving more reliable, resilient power that was, again, touched on by many. And, the last thing around just this whole seamless integration and operation of renewables and distributed energy resources, right? There's a lot to do in that space. And if I have to sum it up, I'd say those are all key areas that AI, analytics automation can play a significant role in the coming years. And, I also loved another context that, this team here brought up today. I personally came from, the tech industry 23 years ago when I spent time in the tech industry, worked at Schneider, which is, really an OEM in the energy space. And then, at an utility today at Ameren. And so really you look at that gamut of tech and how the technology companies, the OEMs in the energy space, the research organizations, whether it's EPRI, it's universities, and utilities need to come together. I think there's tremendous opportunity in front of us for the future.
Thank you, Bhavani. And yeah, the opportunity is huge for this. And it's really what you just said, the OEMs, universities, research organizations, utility organizations that are outside of our industry coming together and working to solve these big challenges. And I really appreciate all of those thoughts towards the future. And the folks that have joined us today have been sharing their thoughts and their questions in this chat. And it's a really, really rich discussion that's going on. So I want to turn our attention to a few of the questions. We're going to take as many as we can here. The first question that I have is for Peter. So Peter, we'd like to hear more about model standards and accuracy standards with regard to quality control, especially when artificial intelligence, machine learning is learning and then making optimized decisions. So it's really about what are some model standards, accuracy standards with regards to quality control?
Okay, so the thing that comes to mind, for example, is the work that was done to try and assess the amount of wind and solar for planning purposes. And the data, it turns out the resolution is very poor. And so the approach that they use, the super resolution approach, involved using adversarial deep learning neural networks to be able to ensure, on the training data, to ensure that a lot of the key features remain as one goes from low to higher resolution. That seems to have worked really well compared to a number of other machine learning approaches that have been used on similar problems prior to that. So I think a lot of it has to really gets down to having the right people and developing the right deep learning strategies to be able to do that. A lot of it rests with that by and large. I find it very interesting if you look at, for example, some of the papers out there working on similar problems, you can sometimes see very different solutions, not unlike many parts of science. But I think as the community grows and we see more collaborative interactions going on, we'll do a lot better with this.
Thank you, Peter. Would anybody else like to chime in on that question?
Maybe I could just say a little bit. You know, the way the grid has been balanced since the age of Tesla and Edison is by frequency. And we have a tolerance on the frequency. It's 60 hertz plus minus 0.035 hertz. And that's been sort of the way to balance the grid. That was the only means of communication between supply, generation, and load in the age of Tesla and Edison. We still use it. Of course, we now have much better communication and with higher fidelity, which is now all the DERs and the IoTs that we have now. And I think it's very important to create some tolerances on terms of how much voltage surge you could have on your distribution network, volt var, things that are very important for electricity industry to be placed in the AI predictability so that you're still maintaining the reliability and the resilience of the grid.
Thank you, Arun. All right, I'm going to move on to a next question here. And this one is about coding artificial intelligence. So should we see a side industry for the electric power industry to develop the coding AI development? Typically, the electric industry does not have the expertise to developing the coding to take advantage of massive data and computing power available. And additionally, how good is AI at extrapolation? Is synthetic data part of the answer, and should the industry do more in terms of generating synthetic data? So that's a really rich question there. Mirna, do you want to start?
Sure, I can start. I think it's always good when we're kind of looking at how we combine industries to make sure that that we have a diverse group that we're working with. And I wouldn't forget about small and medium enterprise innovative companies as well, because I think there's a lot of good work being done out there. So yes, I do think that there should be programs that put people together and that we can look at how to build something better and engage with industry in this way. When I guess moving on to the question about synthetic data and extrapolation, synthetic data is now becoming a really broad topic. So there is all different kinds of understandings about synthetic data. Synthetic data, some people refer to as, kind of de-identified data. So, taking maybe smart meter data and kind of removing identifiable aspects of it for use. And that's one, kind of thing that makes data more accessible. But then there is also synthetic data that's produced. So, and I think that's really important to understand how modeling and intelligent AI-based modeling can create realities around other scenarios to validate them. and to validate, the algorithms that are used to optimize grids and create scenarios around those algorithms that actually trial them in unprecedented scenarios to see how they respond and react. And I think that's really important. Extrapolation is always something that is done based on, people's sense of risk around what you're extrapolating, around the uncertainty, around the value of understanding that uncertainty. And you can spend a lot of time there depending on what the value of those extrapolations are to the decisions that you're making.
Okay, thank you, Mirna. Did anybody else want to chime in on that question?
I just wanted to comment one thing on the training. This next generation of engineers and scientists who are leaving college now are going to be very well versed in machine learning techniques. I know from lots of US and the big European universities, machine learning classes are incredibly popular these days, or even the freshmen are now taking these things. NREL teaches classes to engineers so they can learn to do machine learning programming. Google does it. I'm certainly, Arun sees it at Stanford. Microsoft's doing this. So there's going to be a sort of help, so to speak, from a lot of circles in this. It will be like learning what to do calculus.
I agree. I mean, I call data science broadly as the algebra of the future.
I think that's really well said. The algebra of the future is data science. And to Bhavani's point earlier about the half-life of skills going from 30 to 6 years, I think this is very relevant too. And I know I'm certainly seeing, as I'm hiring folks, there's a machine learning element to folks that are coming out of school, and it's great to have it there. The engineers, the scientists of the future are going to have an AI component to their resume. Let me move us towards probably our last question here, and this one is focused back on our use of artificial intelligence, and the question is, how can we use AI to further improve our asset management and an electric utility? And are there any immediate challenges being faced in implementing and deploying AI based on predictive maintenance systems in the field of the electric power industry? Bhavani, did you want to start first with that one?
Yeah, no, absolutely. I think I actually touched on this one, Heather. The question came in, I think, prior to my description. So hopefully it helped in terms of a few things that, we're already doing in this space, whether it's, with respect to asset performance, asset health. I touched on some of the things we're doing around wind, and expanding that to other generation as well. So really asset health on generation, distribution, transmission, all aspects of it, right? And I think because if you think about the reliability aspects you're driving, you think about the affordability aspects you're driving through it, it's tremendous. In terms of challenges, I really do think it's about how you think about these and how I could touch on a few things that we worked, we're not trying to build these things, in a vacuum from scratch. And there's, Myrna touched on it, several of the folks here today touched on these partnerships and working together. And so we have worked with OEMs, we have partnered with EPRI on some of this. So it really is taking, and then it's bringing our tech talent along with our engineering talent together, because in most of these cases, you're bringing data from multiple sources together, but it's your engineers who are closest to the operations that understand and can help fine tune the algorithm. So it really is, for us, a broad combination of OEMs, technology skills, our Ameren technology skills, and our, engineers from our operations together as we fine tuned it. We've taken the approach of piloting them, right? Taking, for instance, we took, transformers in a subset of our transformers and said, we're going to go after that, look at it. And we were, in the pilot, we were able to, find a good win that, in terms of finding and preventing a transformer failure. So really that helps you then take and then continue to scale it to other devices as well. And so I think part of it is being able to learn and having that mindset of, check, adjust, and continue to, pivot from there. Not your traditional, implementation cycle, or process. So I think that's it's probably a little bit of a mindset shift there from that standpoint. In terms of challenges, I do think it really depends on how you're thinking about it, how you go after these things, and you build upon it. There's a lot of opportunity. I touched on the wind analytics piece on really getting to digital twins, at scale, right, and being able to run a lot of your operations remotely with that. So I think there's a lot more to come there in terms of opportunity. So I'll pause if anyone else wants to add anything there.
I'll say thank you so much, Bhavani, for the response to that question. And we've reached the 12:30 mark. So I really wanted to say thank you to the panelists, Arun and Bhavani, Jay, Mirna, Peter, and Daryl. This was a really rich discussion. I appreciate it. We have a lot of comments and questions in the chat that we're absolutely going to go through. And as we move forward, EPRI has some plans coming up here in the near future. We're going to play a video as we wrap up the panel. And if you'd like to contact us, our website is ai.epri.com. We really look forward to collaborating with you and working with you. Thank you so much for joining us today.